In the previous video, you learned about the fundamental principle of counting that involves the multiplication rule and the generalized multiplication rule. In this video, we shall discuss arranging and selecting of objects, which involves permutations and combinations. Let us define what is permutation. A permutation is the process of arranging objects in a linear or circular manner. In permutations, ordering is important. For example, the ordering green, blue, and red is different from the ordering red, blue, and green. Now let us discuss arranging of n distinct objects in a row or in a column. Consider the three objects labeled A, B, and C. How many arrangements or how many different arrangements can be formed from these three objects? Now in the first position, we have three choices, one from A, B, and C. In the second position, we have two choices each. If the first position is A, the two choices would be B or C. If the first position is B, then the two choices are A and C. Now, if the first position is C, then the two choices would be B or A. Now, for the third position, we only have one letter to choose from, since two of the letters were already used in the first two positions. Now, in this particular illustration, we have C, B, C, A, and B. So we have six possible arrangements of the three objects A, B, and C. And it is given by the formula 3 times 2 times 1 using the generalized multiplication rule. Now 3 times 2 times 1 is equal to 6. Now this product, 3 times 2 times 1, can be written using a special symbol which we call d factorial. So particularly, this is actually 3 factorial. To formally define this, the number of ways of arranging n distinct objects all at a time is given by the formula n factorial, which is the product of n minus 1, n minus 2, and so on and so forth until we reach 3 times 2 times 1. We note here that 1 factorial is defined to be equal to 1, and 0 factorial is also defined to be equal to 1. Now you can find in your calculators the factorial notation so that in the future, if you need to solve problems that involves factorial, you can easily determine the answer. Now the formula for arranging n distinct objects taking r objects at a time is n permutation r, which is equal to n factorial divided by the quantity of n minus r factorial. Now let us consider n distinct objects labeled A, B, C, and D. So n equals 4 in this case. Now let's take 3 objects at a time and list down all the arrangements of the selected 3 objects from the 4 distinct objects. So first we have A, B, and C. So the arrangements are ABC, ACB, BAC, BCA, CAB, CBA. Now, we can also choose ABD as the 3 objects. So the arrangements would be ABD, ABB, BAD, BDA, DAB, and DBA. Now we can also choose ACD as the 3 objects. So we have ACD, ADC, CAB, CDA, DAC, and DCA. And also, we can choose BCD as the 3 objects. So we have BCD, BDC, CBD, CBB, DBC, and DCB. So all in all, we have 24 possible permutations taking 3 objects at a time from 4 objects. So in this case, if using NTR, then we have 4 permutation 3, which is 4 factorial over 4 minus 3 factorial, which is actually 4 factorial over 1 factorial. 4 factorial is 24, while 1 factorial is 1. This gives us 24 possible arrangements. For examples, how many different permutations or arrangements can be formed using the letters of the word format if the letters are taken all at a time? So since we're using all the letters of the word format, we shall use the n factorial formula. Now, since all the letters of the word format are distinct and it has 6 letters, then the total number of permutations would be 6 factorial, or 6 times 5 times 4 times 3 times 2 times 1, which is 720. Another example would be the boys and their respective girlfriends have bought 6 tickets for a concert. In how many different ways can these people be seated in a row if there are no restrictions on the seating arrangement? So if there are no restrictions on the seating arrangements, then anyone can sit anywhere, which means that the total number of arrangements would be 6 factorial, which is 720. Now for the second scenario, each couple is to sit together. So let us illustrate this by a diagram wherein we have 6 positions. Now each couple must be seated together. So a particular couple can be considered as a single object. So therefore we have 3 objects here, and the number of permutations of these 3 objects would be 3 factorial. However, for each couple, we can interchange the position of the boy and the girl, so which means we have 3 copies of 2 factorial. So for letter B, we have 3 factorial times 2 factorial times 2 factorial times 2 factorial, which is equal to 48 different arrangements. Now for letter C, the requirement is that all the boys are to sit together and all the girls are to sit together. So similar to what we did in item B, then the 3 boys can be considered as one object and the 3 girls can be considered as another object. So the number of ways of permuting these groups would be 2 factorial. However, for each group, we can still permute all the boys and also we can permute all the girls. So we shall have a multiplier of 3 factorial and another 3 factorial. So in this case, we have 72 different arrangements. Let us illustrate permutations of n distinct objects taking r objects at a time. In how many ways can a teacher assign 5 homeworks if there are only 3 students available to be assigned? Let's label the 3 students with S1, S2, and S3, and the 5 homeworks with H1, H2, H3, H4, and H5. The teacher may assign homework 2 to student 1, homework 5 to student 2, and homework 4 to student 3. So this is one possible assigning of homeworks or arrangement of homeworks. Now the teacher can also assign homework 4 to student 1, homework 2 to student 2, and homework 5 to student 3. But this is not the only group of homeworks that can be assigned by the teacher. The teacher can also assign, let's say, homework 1, homework 3, and homework 4 among the 3 students. So therefore, using the formula for the permutation of n distinct objects taking r objects at a time, we have 5 permutation 3, which is equal to 60. Now you can also use your calculators to compute this by finding and using the NPR formula of your scientific calculators. The formula for the permutation or number of arrangements of n objects where some objects are repeated is n factorial over n sub 1 factorial times n sub 2 factorial times up to n sub k factorial. In here, n is the total number of objects, while n sub 1, n sub 2, up to n sub k are the frequencies of the k distinct objects in this scenario. So for example, let's consider the letters of the word stat. The letters of the word stat has 4 letters, but there are only 3 distinct letters which are S, T, and A. The frequency of S is 1, while the frequency of T is 2, and the frequency of A is 1. So using this formula, we have 4 factorial over 1 factorial times 2 factorial times 1 factorial. But we know that 1 factorial is just 1, so this is just 4 factorial over 2 factorial, which is equal to 12. Now this time, if n distinct objects are to be arranged around a circular object, then the formula will be n minus 1 factorial. So suppose that we have a circular table and we want to arrange the objects A, B, C, and D around that circular table. So using the formula, we have the quantity of 4 minus 1 factorial, which is 3 factorial, which is computed as 6. Now, suppose that we want the two objects A and B to be seated next to each other or to be consecutive to each other, then we can treat them as one object. So this means that around the circular table, we only have three objects. First object would be the group of A and B, second object is B, and third object is C. So that will give us 3 minus 1 factorial. However, A and B can still be interchanged in their positions, which will give us an additional of 2 factorial. So we have to multiply this 2 factorial with 3 minus 1 factorial. And therefore, this will give us 4. Now, next would be combinations. Combination is the process of selecting R objects from a group of N objects. In combinations, ordering is not important. So we simply select the R objects, but we don't arrange the R objects. So for example, the ordering green, blue, and red would be the same as the ordering red, green, and blue. So the number of ways of selecting R objects from n distinct objects is given by the formula NCR, which is equal to n factorial divided by the quantity of n minus R factorial multiplied to R factorial. So for example, in how many ways can three class representatives be chosen from a group of 12 students? So since we are only selecting three class representatives from 12 students, then this is a combination problem, and therefore the answer would be 12 combination 3. You can just use your calculators to compute 12 combination 3 by finding the NCR symbol in your calculator. Now, another example would be in the Philippine 642 Lotto system, wherein a bet consists of choosing any 6 numbers in no particular order from 1 to 42, how many possible bets can be made? Now, since the phrase in no particular order is in the problem, this means that ordering is not important. Therefore, the problem is a combination problem. So the answer here would be 42 combination 6, and you can compute this using your calculator. A slightly challenging problem would be a bag contains 4 white balls, 6 yellow balls, and 5 red balls. In how many ways can 6 balls be chosen if there must be 2 balls of each color? For this problem, there is a strict requirement that there must be 2 balls of each color in the selection of 6 balls. So there are a total of 15 balls and we have to choose 6. But the 6 balls to be selected must contain 2 balls of each color. So in this case, we shall use the multiplication rule among the combinations for each color. So we have 4 combination 2. This is the total number of ways of selecting 2 white balls from 4 white balls. And we multiply this to 6 combination 2. And this is the number of ways of selecting 2 yellow balls from the 6 yellow balls. And we multiply this with 5 combination 2. And this is the number of ways of selecting 2 red balls from 5 red balls. So using your calculator, you can just obtain the final answer. Okay, now you have learned about the different counting techniques which are needed in probability, which will be discussed in the succeeding videos.